What is the warmest temperature of the day? When does it happen? Now, just looking at the equation, right? 6 a.m. is 0. So this is 6 a.m. and this is 6 p.m., right? Because you're adding 12 hours to it. But if you look at the equation, it's a quadratic equation. Very important. And then also, there's that negative in front, which means it has that reflection. And so I'm just doing a rough sketch. There's my quadratic equation. It's saying, what is the warmest temperature of the day? So if this is the time and then this is the temperature, the warmest temperature is going to be at the vertex. So I need to find the vertex of this. To quickly find the vertex, negative b over 2a. That's your x value. And then your y value, you plug it back in. So negative b over 2 times a. That's negative 8 over the 2, so that's negative 1, so that's going to be 8. So that's t equals 8 in this case. Now if I plug that back in, so this is 64, so that's negative 32 plus 64 plus 32, so those will cancel out, so that's going to be 64 degrees Fahrenheit. So it says, what is the warmest temperature of the day? 64 degrees Fahrenheit is the warmest. And when does this happen? Well, at t equals 8, but remember, we have to count from 6 a.m. So we're adding 8 hours to this. So that should be at 2 p.m. That's the when does this happen. Suppose this cost represents cost in hundreds to produce X thousand pens. How many pens should be produced to minimize the cost? What is the minimum cost? So again, it's quadratic. Visualizing it, okay, I just drew a random parabola. There's no reflection, right? It's not reflecting over the x-axis. So it's facing upward. That means that the vertex, again, represents the minimum. How do I find the vertex? X equals negative b over 2a. So let's plug those values in. So negative b over 2 times a. So that's going to be 10 over 2, which is 5. Now if I plug that 5 back in, you're going to get 5 squared minus 10 times 5 plus 27. So 25 minus 50 plus 27. And then that's negative 25 plus 27. That equals 2. Okay, so now let's interpret it. So we have 5 and we have 2. So the cost in hundreds, so that's going to be your y value. So it's going to cost 200. And then it says how many pens. Okay, this is 5, but then it says the pens are in thousands. So you produce 5,000 pens. So now go into solving some of these. This is a factor by grouping. So we have 8 and we have r squared. And then that's just a 1. So this is 8r squared plus 1 times 8 minus r. So setting each of these equal to 0, you get 8r squared plus 1 equals 0, and r minus 8 equals 0. Well, this one you get r equals 8. Subtract the 1, divide by 8, square root both sides. Can't have a negative inside of a root. So you're going to get r equals plus or minus I'm going to say radical 1 over 8I, because I got rid of the negative inside the radical. That's where the I comes from. And then I guess for now, like that's okay. Now you can also rationalize the denominator. So I could say plus or minus, 1 over root 8, because the square root of 1. Root 8 is root 4 and root 2, so that's 2 root 2. So then I could say plus or minus 1 over 2 root 2I. Now I have to get rid of this root 2 in the denominator, so we multiply the top and bottom by root 2. Now that becomes 2 root 2 times 2 root 2. Sorry, root 2 times root 2 is root 4, which is just 2. So on the top, 1 times root 2 is root 2 over, you get 2 times, and that becomes 2. So that's plus or minus root 2 over 4I. For like number 8, subtract 1 on both sides. Divide by 4. Then you can square root. Yeah, n equals plus or minus 9 over 2. Let's do another bonus one. It says the height h in feet of a model rocket above the ground t seconds after liftoff is given by this equation. Okay, again, immediately quadratic in my brain because that negative's there. I'm thinking something like this, right? Like immediately that's what's visualizing in my brain, and that's what should visualize yours. It says, when does the rocket reach its maximum height? Okay, again, maximum height is the vertex. So how do I find the vertex? Negative b over 2a. So that's going to be negative b over 2 times a. So there's my x. So it says, when does it reach the maximum height above the ground? And that's going to be time equals 10 seconds. Now, what is the maximum height? Okay, so now I got to plug the 10 back in. So that's 500. And then it says height in feet, so 500 feet.